Hey, welcome to my deck and my slinky, same one as 20 years ago. So, what we have is it representing a violin string or piano or guitar where it's fixed on both ends and free to move in the middle. The fixed points where it can't move are called nodes, and in the middle where it can move is an antinode. So, if I start this oscillating, vibrating at a frequency that's one wavelength over its whole, half actually, but one wavelength over its whole distance, we can see that it has a certain frequency. So it's about 1, 2, 3, 4, and if I increase that a little faster now, it's kind of fighting me. It's kind of chaos until I get it exactly double. 1, 2, 1, 2, 1. So it's now double the frequency, and you can see that it's half the length. The wavelength is divided in half. And in the middle, you now have a node where it doesn't move. You could almost walk in from the side there and touch it lightly, like you would on a guitar or violin, and get the first harmonic, at the 12th fret of a guitar, halfway up the bridge of the violin. So now, if I increase again, I can actually feel that it fights me. It reflects a way back to me that doesn't fit my rhythm until my rhythm... I got a feel for it now. My rhythm is now exactly 3 times what it was, and it's 1/3 the wavelength with 2 nodes in the middle. So 3 and 2 nodes at the end. So it's divided into 3. And if I increase the rhythm again, I go faster, it fights me, it reflects back when I'm not wanting it, and it fights me until I get a feel for 4. And it's 4 times as fast. Can we go faster? It fights me. So. 5. I don't know if I can go fast enough for 6. So, we'll give up on 6. It's got to be a slower frequency to start with, or a longer rope. Or I got to go faster. Okay, so here we have the guitar, and I've taped it just to deaden the other strings so they don't interfere with the sound of what we're trying to demonstrate. And I've made this little chart here which shows the wavelengths. So what it's attempting to show is one overall wavelength going up and down like that, and then the halfway point here where what we saw with the slinky, where it kind of oscillates between the two, and then the third one. And it would continue to the 4th and 5th and so on, but I don't want to clutter it up. I'll do that in a cutaway. So I put this chart, I made it to be the same length as the length of the string. And you can tell by looking at it that the halfway point would be this 12th fret here. So if I was to pluck the string without it, you'd see it vibrating through. I can do a close-up and show it vibrating. Now if I was to lightly touch it, instead of ball, we get boom, an octave higher, because it's vibrating twice as fast. If we look at the third waypoint, so we divide that string into 3 equal chunks, we'll have a third waypoint about here. And we get the 5th. 1, 2, 3, 4, 5, the 5th. And if we divide it into quarters, instead of the octave, an octave higher, we get an octave higher than that. We could also touch this halfway point, because there's any of those quarter points will excite that 4 times faster frequency. If we divide it in 5, we get 5 equal chunks. There. That's dividing into 5, which is the major third of the harmonic series. Then divided into 6 chunks, that's half of 3, so an octave higher would be short bundle 6. Where's the 6? And we divide into the seventh. Here's our, coincidentally, is the seventh of the scale. Just a coincidence. But that's our barbershop seventh. Natural seventh. Oops. There's the seventh. The seventh. And it would continue to the octave again, which is, there's halfway. There's quarter way. And there's eighth. Here's a ninth, which coincidentally is a ninth. And the 10th, which is the third again. The 11th we never use. 12, 13, 14, double 7, 15, major 7, and 16. So, here we have where our music notation, treble clef and bass clef, are lined up with their corresponding spots on the piano. So, below the bass clef, 2 ledger lines, is this low C. Middle C is the space between, which used to be all one grand clef, and it was too hard to read, so they separated it. Now, the space below the treble clef is the same as, the one ledger line below the treble clef is the same as one ledger line above the bass clef, and that's your middle C. This would be a G, so on. 2 ledger lines above would be high C, and so on. And what these numbers are, starting with this one down here, is, like on the guitar, if we played that low C, I tuned it down to a C, and that was our fundamental, vibrating once, and we touched it halfway, we would have the second harmonic, the second in the overtone series, which is an octave higher. Then we'd have the third harmonic, 3 wavelengths per length. Then we'd have 4, which is exactly an octave higher than 2. Then we have 5 wavelengths per frequency, which is our major third. Then 6 wavelengths. Then 7th, and now we have a coincidence that it is, and it's flatter than that, that it is the 7th of the chord. And the octave again, which is another coincidence, 8. And there's a bunch of coincidences for the next octave or so. 9 wavelengths, 10, 11 somewhere in between there, 12, 13 somewhere in here, 14 somewhere in there, 15 pretty close to that, 16 right on. In fact, if we look at all of these multiples of the first fundamental frequency, we find that only the doubles are the only ones that are the same as the piano. These are the only true frequencies. So, all the rest, including the so-called perfect fifths and perfect fourths, aren't quite perfect. They're very close. But the third isn't. And a minor third isn't. And this minor third isn't even a minor third. So, all of these notes, not so much this one, but our 7th is way out. Our 9th is not too bad. They're all different except for the octaves. Okay, that is the harmonic series with that fundamental. You could put it anywhere, and if I could have those numbers on a slide and move just the numbers to match up with whatever note was your fundamental frequency, all of those overtones would be like that. And if you look up here, it continues on. The only ones going to be true are 16, 32, 64 way up here. But you can tell they get closer and closer and closer and closer, and there's more and more and more of them the higher you go. Because the difference between the 23 wavelengths or 24 wavelengths within a given length of string isn't really proportionally that much. That's why they tend to get closer the higher you get up. So let's line it up with our C. And there's our harmonic series. 1, fundamental. 2, the octave. 3, the fifth. 4, the octave again. 5 wavelengths is the third. 6 is the fifth. The 7th, the 8th, 9th, 10th, 11th, somewhere in here. 12, 13, somewhere in there. 14, somewhere in there. 15, pretty close to there. 16, 17, 18, 19, and so on. So, here I have a euphonium, which is just a straight length of hollow tube that wraps around from the mouthpiece to the valve. And along the way, these valves are just bits of extra tubing. So unless I put the valve down, it won't go through the extra bit. So all valves do is lengthen the given length of tube. And if you put down the second valve, it's the shortest bit that adds. It actually adds a semitone to the harmonic series. So all of those notes in the harmonic series are now one semitone lower. And if the first valve adds 2 semitones or a tone, and the third one adds 3 semitones. And if you add them in different combinations, you can get all the way down to 7 different lowered harmonic series. So without pushing down any valves, it's just an open tube, similar to a garden hose, which I'll show you next. So, if I'm trying to play the fundamental on this euphonium, it's quite low. I'm an octave lower than that, and I'm going to try and get it. Now, if I was a euphonium player or a trombone player, similar mouthpiece, I could get a better fundamental, but that's one wavelength within the horn. Is 2, like dividing it in half is twice as high. So 2 wavelengths and it's the octave. Now 3 wavelengths gives me the 5th. We're going up that harmonic series. Back to 4 wavelengths, you're back at the octave. 5 wavelengths. 6. 7. 8. 9. 10. I'm running out. And 11 is a weird one anyway. Alright, so that's the euphonium. Now a trumpet, lots of similarities. One of the subtle differences is it's not quite as conical, which means that the flare of the bell and whatever doesn't allow me to get the fundamental. There is a fundamental, but it's a little bit out of tune and weird. But what is the same is the second valve adds a semitone, and the first a tone, and the third a tone and a half, or 3 semitones. So it, like all brass instruments, is just a given length of tube that you can extend by bits. And in that given length of tube, you have all these natural notes, the natural harmonics, which are the harmonic series. So if I was to play, that's actually not the fundamental, and you can tell this is half the length of that euphonium. So it's going to be an octave higher. I'm going to show you that fundamental out of tune and weird, and not go into the physics of why the bell doesn't allow a good fundamental on a trumpet that does on a flugelhorn and French horn and so on. Here's the fundamental. So that is the fundamental. It doesn't fit nicely in the horn, and composers didn't write for it. But they did write for the second harmonic upward. So here's the second harmonic, which should be an octave above the first harmonic. And the third harmonic, 4th, 5th, 6th, 7th, 8th, and so on. And again, a real trumpet player could play much higher still. Great players can play up another octave above that. So, and in that range, the harmonics get very, very close together. So there's another example. All it is a tube that you're buzzing through. A mouthpiece is nothing more than a hole and a bit of a cup shape here to channel the sound and make it resonate. Without that, you have just a simple length of pipe. So here's a length of, it's a conduit wrap, I think, for electrical. Anyways, but it's just a pipe, and if I were to blow through it, its harmonic series is a little out of tune because, again, the bell shape, there isn't a bell, and the point at which it becomes a note or reflects off open air, strangely enough, is quite complicated physics. But it is a direct result of why the harmonic series, which is the same, dividing it into shorter and shorter wavelengths, isn't exactly in tune. And so on. That's about this long. If I was to look at a pipe, I think it's a little longer, and it's a lot bigger diameter. This end. Anyway, though, again, a harmonic series is way out of tune, but that's what that is. This is harmonic series. If I can take a shorter length of tube, here's a shorter length of tube, and by the way, it's just a buzz. That's how all brass players play. So I can only get 2 of those harmonics. It's so short that the fundamental is high. And it's hard to tell what the fundamental is when there's no bell and it doesn't reflect from the same point. It's like the node moves depending on what. This node doesn't move, but the other node does. So yeah, I can only get really 2 decent harmonics out of that. Okay, a really short length of horn. So one good harmonic. Okay, I touched the second harmonic, the octave up. We might be able to extend the length of that. And, oh, it's like I had that worked out. Beer, please. So. Okay, so there's probably the fundamental, very bad one. Kind of like the trumpet. Octave. Fifth. Octave again, a little flat. And the third. So I can't get very high up the series because it's not a very long horn. So, what about woodwinds? What about woodwinds, you ask? Well, it's the same thing. So, if you start with, say, a very short length of pipe, like this teeny weeny sopranino, so that's its fundamental. That's one wavelength over the whole thing. If we blow harder, the same fingering won't change anything. We'll go up an octave. If I blow harder still, it'll go up the fifth. And I'll spare your ears. It'll go up to the octave and the third and so on if you can blow hard enough, and all things being equal. On a longer length of pipe, the flute, if I close all of the keys all the way down, it's essentially just a tube this long with a way to excite the air, like instead of buzzing, it's going to oscillate in and out of that hole, and the other end open. So at this length, we can get that's a low C. Okay, and as I overblow it, it'll go up that harmonic series. One wavelength. 2 wavelengths are the second harmonic. Octave higher. Oops. The fifth, third harmonic. The octave again, or fourth harmonic. third or fifth harmonic, this sixth harmonic, the seventh harmonic, and maybe if I'm lucky, no, not lucky today. Anyway, runs out about the eighth. On my alto flute, it's bigger, I can get about the eighth, and that's it. So the same is true for every instrument. I could even show you a soprano sax, you ask. So again, if I close it down to its lowest note, that's one wavelength. Everything is closed down, all the keys are closed to the very end, and that lowest is it's B flat, it's on the A flat. And if I overblow it, go. There, octave up, second harmonic. The fifth or third harmonic, and so on. I'll spare you the rest if I could get them. What about a didgeridoo, you ask? Well, this didgeridoo does, and did, and will. Okay, dear didgeridoo, do this. Fundamental. And first, second harmonic. Out of tune, cylindrical, and so on. But how the didgeridoo makes it sound is gets that buzzing fundamental. And then you sing at the same time. And so on. Didgeridoo doesn't anymore. Okay. The original horn. So here's just a tube that wraps around that top off, so it's got an opening on the other end. And if you play, horn players want to put their hand on the bell. Fundamental. That's second harmonic. There. Third harmonic. That's about all I can get out of that tiny little hole. Okay, how can you have two wavelengths happening at the same time? Well, imagine this going back and forth like this, the fundamental, and the second harmonic of the harmonic series, the second half of it, imagine if it also was going back and forth. So, here we have the guitar, and its strings are fastened at each end, the nodes, and are free to move in the middle, in between the antinodes. So if I pluck the bottom string, this low E is vibrating its fundamental. It's also vibrating a whole bunch of overtones at the same time, which we can't hear individually, well sometimes, but we hear those overtones as its timbre. This is the tone of this guitar, its color. Now, if we can imagine it going back and forth like the slinky, you could probably see, I'll do a cutaway or a close-up to show, that it's all fuzzy in the middle, and you can imagine it going back and forth hundreds of times per second. Now, if we were to find the halfway point of that and touch it there, that would stop the string from moving back and forth there, and it would be forced to only do its second harmonic, like the slinky did. And there it is, an octave higher, vibrating twice as fast. So that's what this chart is meant to show, that here's that point. If I line up the beginning and end, that point is on the 12th fret. It's the halfway point, and if you create a node there by limiting its motion, you get the wavelength cut in half, an octave up. Now you could do the same thing at the third waypoint. So if you divide the string into three separate equal pieces, you'll see that that would be this point here. So a third takes us to just beyond that fret, and 2/3 and the 3/3. There's your 3 equal chunks vibrating like this, and then the opposite way. Okay, so if we touch it on that point, here's the fundamental, here's the octave, here's the fifth. So we've got octave, then a fifth. Okay, if we continue up and we divide it into quarters, that's this point here. I only tried to draw in those first 3, but it's going to get kind of cluttered if I draw in the 4, the 5, 6, 7, so on. So here's 4, half of 2, 1, 2, 3, 4. And if we touch it at that 4th way, it's about here, we get the octave again. Boom, then the octave, and then the 5th, and then boom. The octave again. If we divide it into 5 equal spots, we've got 5. Any of these points we could touch it at. So let's touch it at this one here. 5. There it is. And if we touch it at 6, exactly an octave higher than doom, 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 doom. And then 7, and then 8, 9, 11, 12. It's hard to get the one in between 12 and 15, but anyway, there they are. So halfway can be, yeah, and the 3rd way is right about here.
Right there?
Yeah. And that's the 5th, right? Then back to the octave would be 3/4, right there.
Right there? Cool.
And try a little bit closer, because there's a range. You can get it in, and you get it right on, you get more volume. Okay, so that's, yeah. And come this way just a little bit. Yeah, okay. And then here, and back to the 5th again. And that's the flat 7, and then the 8, and 9. And then you went way up to the 13th. Just above the 5th, as if that is another funny note. But these ones that are hard to get, the 11, 12, 13, see how close they are over here? The same as distance they are here.
Yeah, they've got no access to them.
And you can't get those, but what I'm saying is, when you get them all in a row like this, they just get closer and closer and closer.
Yes.
But what you can do, let's say the 12th, look how close that is. I wonder if that's showing. 12 is tucked in so close to 13 and 11. But if you look for here, that's a 5/12 and a 7/12. Right, so each one of those notes, like, let's say you divide it into 4. Well, you've got 1, 2, 3 notes to pick if you divide it into quarters. Then you divide it into 12s, you've got 11 spots that you can pick. That will be one of the 12s. So it's just see if we can get that 12th, and then we'll try one of these.
Okay.
Because you've already gone, well, you skipped 11 and 12, and okay.
Yeah. So is that the octave?
Yeah, that's the octave again, yeah. Then the major 3rd. And bring it this way just a little bit. Yeah. And again, bring it this way a bit. Good. And then the 7th. Now you skip the 8. Okay, so that's 8 that's 8. That's 7. That's both of them back and forth. You go one higher, you get 9. That's 10. That's 9. That's the 10th. Now, that funny one is 11 and will be 12. We touched it. You went 12, 13 there. Okay, so
Yeah, I
you
heard
can get them. But let's try for this one here is like 5/12. There. That's it.
Which one?
There. Okay, that's the 12th harmonic.
Twinkle, twinkle.
And it's easier to get in terms of what's around it. The major ones around it are further away.
Wow.
So what you're doing when you play the node, which is a point where it's staying still, because when you touch it, it can't vibrate anymore. Right? So you're inducing a node which takes out the fundamental. It filters out the fundamental and only leaves everything that divides into this half and that half. Whatever exists over here exists over there. So that's what you're doing by touching the harmonics, is basically eliminating that halfway point, right? Then if you touch it at the quarter way, you would eliminate this harmonic and the
So
fundamental.
which is the quarter?
Right there. So you're back to the name of the string. 2 octaves higher. So if you wanted to play taps or something, or the bugle call, it would look something like this. There. Yeah. Yeah.
Oh, for heaven's sake.
Cool.